Okay, this video we're going to look at a couple of neat things you can use a normal vector for. So last video we saw when a line is in Cartesian form, or scalar if you want to call it that. So here's the general form. The normal vector, which is going to be a vector perpendicular to that line, is going to be the coefficients a and b. So let's look at these two lines that I have here, first pair. So the normal vector, that first one I call a normal 1, is 1, 3, and then normal 2, that second one is going to be 5 and 15. So I can use these vectors to see if these lines are parallel. So over here, on the one that has a larger coefficients, I notice I can factor out a 5, and the result is the same vector as the other line. So these two lines would be parallel. So again, same test to see if they're parallel between two vectors, but you can use the normal vectors for this one. Now this next pair, normal 1, so the first line, the normal is 2, negative 3, and the second line, the normal is 3, negative 2. Okay, so why don't we test to see if these two lines are perpendicular? So that we know if the dot product between the two vectors comes out to be 0. Sorry about that. So 2 times 3 is 6. Negative 3 times negative 2 is positive 6. So you can see here, these two lines are not perpendicular. Now, if that result was 0, just like we saw in a prior video, then we would conclude that those two lines are perpendicular. Point being is that you can use the normal vector to test for lines being parallel and for lines being perpendicular. You can also use the normal vector if you want to find the angle between two lines. So we know we use the dot product for that. So for the dot product, you need those two vectors. So you can actually use the normal vector, same application, so you can look at that prior video on the dot product, and you can be able to calculate the angle between two lines by using the normal vector. So those three tests are the same, the ones for parallel and the ones for perpendicular and for calculating angle between. The advantage is when the line is given in Cartesian form, you can actually use the normal vector, which is not too bad to take away from that.